record to this computer. Okay, I managed to remember to record. Excellent. All right. So what have we done so far in this class? We've really learned how to use R to grab data, do some rudimentary data manipulations, and output that data into some sort of plot, whether it's a bar plot or a density plot or um, some sort of a line plot. And we've done this across a number of different data sets. Um, we started off looking at what was the one that we looked at first? We looked at looked at the cigarettes data set. Um, we looked at then we pivoted over to bank wages, right? And then we had this kind of a hairier one called NYC flights, and that one had some relational data in there where we can merge fields in and out to kind of deepen or enrich in our data set using the joins. Really, what this has all done over the last, I don't know, so we're what, June 16th? Let me look at the calendar here real quick. Let me like write myself here. So basically, let me go look at the month. June 14th. Where's my other calendar? I don't like this calendar. I don't like Outlook's calendar. It really makes me upset. Okay, so we're like into week 3. Next week is week 4. So over the last like 2 weeks, you guys have gotten about 90% of the way there of like an incoming intern at the Fed, right? Like you're kind of doing what we would expect an intern to do, which is pretty cool. Like you guys are rising sophomores. Our interns are usually rising seniors. And so this puts you in a pretty good position, right? Uh, for actually doing some real work. And you guys can actually do some real work now. And I looked at your homeworks, everything looks good. I don't really have any real complaints. There shouldn't be really any complaints. The stuff is, I mean, like on a scale of like 1 to 10, if you were to give like a difficulty level to some of this work, what would you guys put that as?
I'd say a five.
5, 4 or 5, kind of like appropriately difficult for summer, right? Like we're not like in the throes of a full semester. You guys aren't hitting your 3,000 level classes yet. Maybe you are. I don't know. You guys are LDC, Lisa Cook scholars. So I wouldn't shock me if you're going to graduate next semester. You guys are brilliant. Um, I'm serious. Like I just got a bunch of graduation notices from our last semester, and it's just like these. Every single one of them is going to go off and just be like an absolute just monster in industry. Like whatever they do, whatever they touch is just going to be gold. And I expect nothing less out of you guys. So it wouldn't shock me. If you allow me to just ingratiate my students for a minute. Um, so that's really given us the opportunity to kind of go through and like do a lot of, I guess, kind of interesting stuff as we've done, right? So we've gone through, we've done some, right, mutates, a lot of plots. And like, if you've noticed, like there's a kind of a pattern here to the work that we're doing, right? We're not really preparing data sets, right? In the sense of like our output, like how many times have you output anything to a CSV file in this class? I don't think any, right? And I think there's only been one time that we actually like saved a data set, right? If I'm not mistaken, let me look. Yeah, the Chicago flights, right? It was the only one. Like, so those were, if you remember from the airline, was it airlines or flights? Yeah, flights data set. Um, we filtered by flights going to Chicago. Um, and yeah, that was really it. More than anything else, we've been taking data, we've been doing some basic manipulations, and we almost immediately dump it into ggplot, right? Like that's like our workflow. We start with data, we get it into some sort of like reportable form, bless you, and then we immediately go into a plot, right? And that's kind of your general workflow almost always, right? Unless you are preparing something for an economist, um, which does happen. Like unless you're preparing something for like a regression, which is kind of like beyond the scope of like the summer. Almost everything we're doing is getting from data to plot, data to plot, data to plot. Because why do I want to go to plot? Plot because that's how I communicate my results, right? Obviously, like that's how we look at things. Um, and so yeah, like that's really kind of the sort of overview, or like I guess kind of the gist of it. Let me go into AER real quick. See if I can find a good example here. I'm looking for like a good example data set this morning. Um, where's my, is it CA schools? I think it's California schools. Is it CA schools? Where's my data sets? Linear regression. That's not what I want. That's not what I want. That's not what I want. Help green. I think is it in Stock and Watson? I'm not sure. Let's go look. Let's go look. Let's see. Data, CA. Yep, CA schools, CA schools. All right. So I believe if you don't have AR installed and loaded, let's go ahead and get that done. Um, so let me go into here. Let's get rid of baby names, get rid of Chicago flights, get rid of unrate. Let's go down till here. So if you haven't installed tidyverse, and what was it? And AER, library, tidyverse, AER. Yeah, we've gotten far enough along. I'm like kind of struggling for like material here. But fear not. The reason why I say that is I want to make sure you guys are in a good position to tackle the project. So I want to try to rip through one last thing that I want to expose you guys to before we get to our class project. And our class project is going to be an interesting one. And this is going to be something that you guys will have you so for the economic students in among us, this is data you're probably going to touch quite a bit. It's going to be um, the BLS data. They've got a package called Tidy Census, and we're gonna have fun with that. We're gonna have fun. So, but before we do that, I want to go over one last thing, and that is what I consider like tidy data, right? Tidy data, tidy data. What does tidy data mean? Well, we've been dealing with tidyverse. Does tidy data have anything to do with tidy? Kind of a little bit. It's really more about like how do you get your data? Like what are the principles of like good data management, right? Like and good data management really is based on what you intend to do with that data, right? So if you're just going to, save a data table out, you want to have something that's just sort of plottable, that's fine. But um, you know, uh, like what do we want things to be in the right sort of shape before we start passing it off to functions, right? And so, what did we notice with, for example, ggplot, right? Right. So I take some data, right, right, and I feed it into ggplot, right, and I do like a geom. Let's say so. It's going to do a line, right? So we're going to do some line plots. And I've got my aesthetics, got my X equals date, my Y equals a saved value, and my color equals some sort of group, right? Right. Let's say that this is our workflow, right? Without looking at this, without knowing what data is, right? This is just an example, which is theoretical, right? Without looking at this data, what do I expect things to look like in data just based off of this, right? So what I expect is at minimum what? I need a um, data frame with three columns. One column is date, one column is value, and another column is group. And I would expect to see in group, right, some unique values in group, right? However many I have. I'm not, I don't know how many. If are you guys familiar with a balanced or unbalanced panel? Have you heard that term before? So if I have data and it's considered balanced, if I have observations, so let's say I have monthly observations from 2020 till today, a balanced panel would have values in every single one for every single grouping, right? An unbalanced would mean I have, different lengths of data for each layer of grouping, right? But at minimum, can I draw? Do I have the ability to draw? Annotate, right? I can annotate. Let's go and annotate. I do this to say my data here, right? So I'd expect three columns of data, right? Two, then three, right? I expect date here. God, you're gonna watch me just struggle through this. Expect the date here, right? And I expect some value, right? And then have some, uh, say, group, right? These would be my three, right, kind of columns here. And in each of these observations, what I would expect to see is some differentiation of the data, right? So I expect, let's go here. These are observations. And in the group column, I would expect one, 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 and then maybe two, two, right? And so I'd have, whatever values here. I'd have whatever date values here, right? But I would expect there to be like, unique values within the group. So when I plot this out, what is ggplot going to do? It's going to grab these groupings, right? It's going to assign some sort of factor level to it. And it's going to plot out the X and Y's that are associated with these values, right? And it's going to assign a unique color to each one of these. This is what we consider tidy data, right? The data is already set up for what it is that we're trying to accomplish. When does data not end up being tidy? Well, data like rarely, if ever, is set up kind of the way we want it. Get rid of all of this. Data is if ever rarely, does it ever rarely look like, oh, dude, give me back my cursor. There we go. So we know from this data, right? We know if it's spelled correctly. Now that this data has at least three columns, right? One date, two value, three group, and in group, there are at least one unique values. I would expect to see multiple lines plotted, each with their own color assigned to group. Right? That's kind of what I would expect to see. We know that automatically from this plot. That's if the data is doing what we expect it to, that's kind of what we would expect to see. Let me go here. So what about, let's see, let me share up this. This is a pretty good illustration, I thought, of kind of what we're talking about, right? So like, what is tidy data? Like tidy data, in effect, right, is it has kind of like three sort of key components, right? Each variable has its own column, each observation is in its own row, and each value must have its own cell, right? Those are kind of the principles of data, right? So we kind of went through, we saw it here, right? Like each variable must have its own column. Well, each variable got date, value, and group. Each observation has its own row, right? So each row represents an observation for uh, 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 I'm sorry, each row is an observation for whatever this group was, and each value must have its own cell. And so we have values that are contained in the cell. Um, are there cases where this doesn't hold true? Absolutely, right? And you've seen those in practice, right? So, for instance, um, we've got text descriptors in a field, right, that can have multiple values. So you've got a spreadsheet and people want to manually enter in, let's say like it's a spreadsheet tracker. God, I dealt with this a lot early in my career. People will often put multiple values into one Excel cell, right? And you go to export that to R so you can do some manipulation on it. Now you've got a cell that has more than one observation. Like it gets to be a bit of a pain. Or you've got data that is sort of in one form that doesn't really lend itself very well to the kinds of things that we want to do. And let's go ahead and go over an example of this. Let's see, CA school. Let's go to the CA schools data set here. What do I want to look at? So I guess first off, is this a tidy data set? Well, I've got distinct values, right? Each variable must have its own column. So I've got district, school, county, grades, students, teachers, so on and so forth. Yeah, that seems like it meets its own criteria. Each observation must have its own row, right? So I've got, what are the observations in this data set based off of? Let's go and take a look. Is that true? CA schools. So it's a data set that contains data on test performance, school characteristics, and student demographic backgrounds for school districts in California. When was this data published? Do I have a date on here? Do I have a date in here somewhere? I do not have a date in here somewhere. This is part of Stock Watson 2007. So we can assume that this is probably, oh, here we go. Data here from all 420 K through 6 and K through 8 districts in California with data available for 1998 and 1999. So this is from 1998 and 1999. These are all observations of student test performance in either K through 8 or K through 6. Um, you know, does this qualify as tidy? Well, we've got observations in each. We don't have any NAs. Each cell has just a single observation. This seems pretty reasonable, right? This seems like we're kind of in the right ballpark. Um, However, does this necessarily comport to what we want to do? Well, what is it that we want to do? Well, what I may want to do is compare, let's say, English and math scores, right? Or reading and math scores by grade level. Okay, well, do I have necessarily the right format to be able to do this? Well, it's less clear. Um, Depending on kind of what we want to do, we may want to have, um, some of these values in here as column headings, and we may want to have some of these column headings as values. And we call that pivoting wider and pivoting. You're not even looking at my screen. Gosh, I like totally sharing the wrong thing. Um, we may want to spread things across. Um, we may want to spread our data across different dimensions for different purposes. So dealing with untidy data was our first step. So determine what are the variables and what are the observations. And the second step is just deal with some common issues, right? And so, one variable is spread across multiple columns, right? And, we may need to pivot longer. If you have one observation scattered across multiple rows, right? We need to pivot wider. So can we think about what those situations look like? So let's say, for instance, um, I have data, right? That looks like this. My data
We still
looks,
see the slideshow.
Yeah, and I'm gonna get the hang of this one day, I promise. I'm gonna get the hang of this. Here we go. So let's say data looks like, so what do we mean by data spread across multiple columns? So what if I did, let me see, blah, blah, Chicago flights, year, month, day. Do, 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 do. Let's see. All right, let's do this. Let's do this. Okay, I'm gonna do this. Let's use an example. Let's just go back to our flights data set real quick. Can I do that with CA spools? I feel like I've done this with CA spools before. Let's do this. Yeah, let's do this. Let's do it in the CA schools. CA schools. Let's say I've got CA schools, and right now this is fairly tidy, but what if I had this? What if I had this data? What if I had all of my counties going across as columns, right? So for instance, at CA schools, let's do a pivot wider. And I'm going to do names from equals, is it county? Yep, county. And then values from equals math. Is that right? Is it math? Let's do that. Let's go to a view. Right. So this is not like uncommon data that you might see here, right? Like, this is actually kind of pretty common. So I've got kind of counties going across the top here, sort of off into infinity until we have sort of all of them here together. And then I've got a lot of NAs that are in here. That doesn't make a whole lot of sense. And then I've sort of got values interspersed all over the place. Like, this is a very common like data set together. Like, someone does a pivot, right? And they send the pivot over to you for manipulation. Right? Like, how do I think about managing this? Like, how do I think about kind of getting to some sort of stable, I guess, placement here. One thing we can do is we can, obviously we did a pivot wider here. We can undo that with a
I'm
pivot
getting an error.
being error. If you do this one, what's your error say?
Um, it was that CA school's not found.
I'm assuming you've got the AR packages installed and we've loaded the library AR.
Do I have to
And
do a
then,
new one
oh,
for
and then
this new?
let's do data CA schools. Try doing data CA schools first. Oh, do inserts now. Go. There we go.
It still says it's not found.
Uh, can you try doing library AR? Not just do like a library AR like this. And then do data CA schools.
Okay.
And that should get you something along the lines
And try it
here.
again.
Yeah, give that a shot.
It says air and pivot wider.
Let's go ahead and share your screen. You stop my share.
Okay.
See, schools subset doesn't exist. Oh, county's misspelled. You got a U between the T and the Y.
Oh,
Here you go. Let's run that. See what you got. Just gonna view. We're gonna see what you got. There we go.
okay.
See, yep. And if you scroll over to the right, you'll see that there's like a bunch of like right now I've got like a bunch of columns where I've got like county level stuff, right? A
Okay.
bunch of NAs because the way our data is just sort of arranged for the purposes of this exercise. Um,
Hmm.
yeah, that's kind of what we're looking at here today. And I apologize, it's gonna be a little of a clunky lecture this morning. Gonna give my apologies up front because this one is a little bit of a weirder lecture. This is kind of like I thought I had a good data set for this to be able to look at. And it turns out that I really don't. But anyways, yeah, that kind of gives you in a sense of like what you can do. Um, let's say I wanted to pivot. Oh, I would do pivot longer. Let's do I know what I want to do. I know what I want to do. This is exactly what I want to do. It's exactly what I want to do. All right, let's get rid of this. Let's start with the CA schools. Okay, so let's say I want to take my CA schools data and instead of having my reading and math scores going across as columns, right? What if I want reading and math to be factor levels in data? Like I want to plot this stuff out, right? So let's say that I want a plot. Um, okay, this is a good example. This is a good example. Here we go. Let's let's say I want to have read and math as factor levels because I want to generate a dot plot with both in the same chart, but with different color dots based on the score. Okay, cool. So that's kind of my objective. I want a dot plot. I want my dot plot to have reading and math right as different colors on my chart. And let's see, what do I want my X and Y axes to be? What are two good X and Y axes, guys? Let's see. What are two good X and Y axes? Two good X and Y axes might be, let's say, we're going to need school. So this is all arranged by school. These are all schools. Um, so what do you think are important factors for test scores? What do you guys think?
Students,
What about students?
the amount of people taking the exam
Okay.
at this.
Okay. So let's see. Student teachers. Maybe said differently, like the student teacher ratio, right? All right, student teacher ratio. All right. So student teacher ratio. So what fact? Hey, let's explore. Perhaps maybe student teacher ratio. All right. What's another thing? Maybe parents income. Like parents level of income might be important, right? So think about it in terms of access to resources, like as a proxy for access to resources, right? So the more money a parent makes, the more access to, let's say, tutoring they may have, right? Um, what do we know about the correlation between income and job type? right? So generally speaking, like the harder the job in terms of like the more mentally taxing the job, generally speaking, the more money you make, right? So like doctors, lawyers, engineers, right? They tend to be higher in the income spectrum compared to, let's say, like administrative assistants or custodial folks. Not always the case, right? But generally speaking, you're right. Like you can kind of think of it as a proxy for a bunch of different stuff, right? Between access to resources, right? Kind of parents' IQs, right? You can kind of mix and mash like a bunch of different things in there, right? But you can maybe think about it in terms of like access to resources. Let's do that. So let's look at uh, so soon to ratio, maybe parents, income. What else? What else is in here? Expenditure, right? So this is the where's expenditure? Expenditure. Yeah, the expenditure per student, right? It's the amount of money that a school is spending per student, right? Maybe that has some sort of relationship, right? So as a school spends more per student, in theory, you would hope that that maybe produces a better student, i.e., like you get a better score. Um, I think what you may find is that that isn't always the case. But these are possible, right? Possible. We don't know for certain, right? This is kind of what we're going to explore. So let's take our CA schools. Let's go ahead and this is all data organized by school. So I want to select. So if you remember, we've been doing a lot of filters. Filters allow us to filter out rows. Select allows us to filter columns. So I want the school. What else do I want? Let's pick, for this example, I'm just going to do income, district average income and US dollar is 1,000. Let's do income, and I want reading and math. Read, math, right? These are sort of three columns I want. Now let's remember I want my scores, right? I want to create a dot plot, and I want the dots associated with the respective reading and math scores. And so on the y-axis, right? So this is the dependent variable. I want my score. On my x-axis, I want my independent variable. And so it's going to be one of these three factors, right? So, you know, we can think of the sort of the function we want to create is, score is a function of x, right? Where x is one of the factors above, right? So I can do a pivot longer, right? So I need to be able to figure out how to, so if I want to color code this data, I need this read and math to be in its own column, right? Okay, I need this read and math to be in its own column. So how do I do that? I can do a pivot longer, right? So what I can do is I can take this data, instead of having it going across in columns, I can take read and math, put that in its own column, and the values that are in here are going to go in their own value column. So we're going to do that with pivot longer value, let's say names from, what's names? Actually, we need to do, so which one do I want? I want read and math. I want to play it read and math, and I want to ignore school and income. So I'm going to ignore school. And then I'm going to do names to equals, let's say subject, and values to equals, let's say score. And hopefully, if I did what I want to do, it should produce Oh, nice, nice, nice. All right, so what did we do here? So let's go into pivot longer. Let's examine this down. So pivot longer takes a bunch of arguments. Pivot longer takes data and or calls, and it allows us to do assign where I want the values to go and where I want the names to go. So we've got this some data here, and then I've got names to and values to, right? And so in here, what do I want each row? Each row I want to have what? For each observation in this new data set, I want to have a school and I want to have an income. And but what I want to have unique is I want the subject to go in its own column, and I want those values associated with that subject in its own row. And so that's what this allows us to do. That's what this allows us to do. So if I do that, I can now type it into ggplot. Geom line. Oh no, geom points. Right, I can do geom points equal yes. So x equals say income, y equals score, color equals subject. And if I do that, I should see a dot plot on the x-axis. I should see the income going up. On the y-axis, I should see the scores, and on the inside, I should see the plot, the each of the points colored by subjects. And I should have a little legend in there telling me what each color represents. So let's run that. Huzzah. Good golly, I love it when I run something and I don't get an error and you guys have to watch me struggle through it like I did earlier in the lecture, trying to find the right data. So what do we see? Give me your interpretation of this.
It's kind of clustered, but it kind of looks like an increase of scores with income.
Yeah, there's like there's a big blob here at the bottom, right? All right. So it looks like if you want to get from, let's say, if you want to get to like a, let's say like a 690, right? Let me go to help. What are the scores here? Let's go back here. Does it tell us what these scores are? I'm assuming it's like what? Say math. Average reading score. Do I get a maximum? I don't. Let's go ahead and just real quickly, let's see what the maximum score in here. Max. CA schools. Actually, let's do this in tidy. Do a summarize. Right. So the maximum values that I have in this data set are 704 and 709 and a half. Let's pretend for a second that like this goes up to like maybe 800, right? So it's kind of like an SAT in a way, right? It's on a score from 0 to 800. Let's save this real quick. This is speak 3.r. Say it goes to say 0 to 800. So back to our analysis here, right? Like if I want to get above a 690, right? If I want to get to the 700s in this for a school score, right? Where do I typically see those?
In higher income.
That's right, in the higher income. Let's say as a H line, Y, and intercept equals 700. There we go. So this is 700 right here, right? And so it's really those scores, right? Those schools that had the higher incomes, um, that experienced, right, the highest scores. However, is it like exclusive to those schools necessarily? I mean, here, like I've got an average income of, let's say, 30. So this one's in $1998. So we got to sort of appropriately calibrate ourselves. The highest score in total looks like it's almost like a tie between in math, right? Uh, a school like, where the parents had an average income less than $30,000. I've got another data point over here where it's more than $40,000. So it's not entirely clear that, right, like to get these like a specific score, that there's much relationship with the income. But you're right, like in general, like the schools that had higher levels of income, right, saw higher test scores, right? That's sort of like the general trend. What about so this is by income, right? What about by let's say expenditure, right? We can just kind of do the same thing here that we did. Oh, let's say by expenditure. Replace income with expenditure, or yeah, replacing with expenditure. And what do I see? Is there much of a relation between how much they spend per school and test score? A little bit, right? There is some, right? So schools that, in general kind of spend more appear to have, um, appear to have higher scores. Was that necessarily the case though? Was it as clean of a relationship as we saw here? Right? Do we see those points cluster on this kind of almost like this 45-degree line that we're showing? A little bit. I mean, there's still this blob in the middle, right? There's still this big bucket of students right here in the middle, like right around, like, let's say $5,000 per student, right? So if I spend between 4,500 and 5,500, I'm getting a lot of bang for my buck. All right. I really got to spend almost twice as much, right, to really see some higher scores. But am I always getting those higher scores? Well, not really, because I mean, I've got a school over here that's spending like what, over $8,000 per student, and I'm not really seeing the scores, right? So what can we think about that expenditure, like that expenditure field as? Like I get what can I spend money on a student for? Right? What are sort of the two key things? I can spend money on a student to what? It's a great student, I'm going to make them better, right? Or I can take a poor performing student and make them kind of get them up to standard, right? And so the expenditure here may not be necessarily related to, just the total effort that you're putting into, these sort of rich schools that are spending a ton of money um, on getting their kids into Ivy League schools, right? This could be like, you've got an immigrant heavy population. The parents, you've got, non-English speakers in the home. And so the school has to spend a lot of money on ESL education to get those students kind of up to the standard and get them performing at a higher level, right? That could be the case. That could honestly be the case. And you're going to spend a lot of money on those students. And that could be the case. And so, it's not necessarily that schools are spending good, pouring good money after bad. It just, that maybe just a situation like the school has a lot of non-English speakers and they need to spend a lot of money on ESL teachers to get them up to the state level standards. What about the student teacher ratio? Let's see, student teacher ratio. So let's go ahead and do student teacher ratio. Let's do, so for student teacher ratio, do I have a variable that is student teacher ratio? I do not. I do not have student teacher ratio. But what I do is student teacher. So I can do student and then teacher. And I can say mutate. I can create my own. So I'm going to call it STR for student teacher ratio equals students divided by teacher, right? And so that should get me the number of students per teacher, right? And I want, let's see, and I want to get rid of, say, students and teacher. Let's see here. I'll get rid of those two. And I want to now do school STR, score, income. I want to change it to STR. And let's get rid of this intercept here for right now. Student does not exist. Thank you. Thank you. Thank you. Thank you. What was it? Students, teachers, students, teachers, students, teachers. There we go. So does student teacher ratio have an effect? Kind of get a sense that there's some relationship there, right? A little bit, right? So the lower the number, so the less students there are per teacher, right? You can kind of see there's a vague sort of downward slope to this, or a downward trend to this data. So there might be a kind of a loose relationship between student teacher ratio and the overall scores, right? Which kind of makes sense, right? Like you want student teacher ratio to be pretty low, right? You don't want it to be necessarily too high. And I think in Georgia, it's like, I think by law, they try to keep it under 20 students per teacher, right? They want or 25 students per teacher, something along those lines. Why is that? Because at some point, right, you have too many students for a teacher to be able to reach. And so if any kid has a question, or if you need to kind of go over a lesson again because it was particularly difficult, those students that need the most help, are probably not going to get it. And so it's going to have an effect on those, scores. But again, we see this big blob here, right? We see this big blob like right in the middle. So in general, we can kind of think of like, well, it seems like most schools are kind of average, right? And then we've got these sort of exceptions on both ends. But what we're able to do though is by using this pivot longer feature, right? We can take our data and turn it into something that's a little bit more, right, trackable for ggplot, right? And be able to get these different colors in here. Does that make sense? Can I see how we did that? Was there anything particularly did I not is there anything that I didn't land here? That seems a little confusing. I use pivot, well, yeah, I use pivot longer a lot. This is one that I use a lot. Purely because I want to get things ready for ggplot, right? So the data that you most often get is going to be in a wide format. Very rarely is it going to be in a long format. And so getting into a longer format is something that is very, very important. Let's see now. Gosh, I wish I had the data set available to us, but they deprecated it. That kind of throws me for a loop here. Let's see now. All right, so let's go into this now. Let's take a look at, so I'm going to fire up your Googles here. I'm going to fire up our Googles. Just checking out my little World Cup action. Let's go ahead and look up Tidy Census. So go into Google, type in Tidy Census, TIDYCENSUS. This is project time, guys. And I'm going to throw you in the deep end. Not because I hate you, but because I know you can do it. I know you're capable. All my LDCs out there, all my LDC scholars. But more importantly, all the students in my class, you're ready for it. So you guys able to hit the screen? Okay, good. All right. So Tidy Census is a package that makes life particularly easy for us. Tidy Census takes all the data that is contained in the census data, and it basically gives us a bunch of functions to be able to manipulate data in a way that is easy interactable. If you've ever had to deal with census data, they have their own database. It can be a little overwhelming, more than a little overwhelming. It can be very overwhelming. And this does it in R for us and in a way that we can quickly get to results. Is this a data set that I am particularly familiar with? No, or a package I'm particularly familiar with? No, it is not. So we're both going to learn together on this in some sense. I just found this last night. I was actually hoping to use some other data, but unfortunately that got deprecated a couple of years ago, and that made me really upset. But I fired up my Claude and I said, "Hey Claude, I have a class and I want to get these guys started on some projects here with a fairly consistent data set." I said, "You know what? I think Tidy Census might be the way to do it. It's a little difficult, but it sounds like your students are A scholars and they should be able to handle it." So let's go and let's play with Tidy Census. So I'm going to break out of our lecture stuff here for a second. I should have a new project called a class project. Let me go into class project. Let that load up. So you guys can do this as well. Start a new session called class project. So it's nice and fresh and clean. Let me check my Outlook to make sure that I'm not missing any students. Because I remember was missing class yesterday, and I still feel really guilty about that. So when we start up a new project, we have to get our environment ready by installing our packages. So I'm going to install Tidyverse. Then I'm going to install this other package called Tidy Census. That's going to run a bunch of stuff in the background here. Once that's done, we'll load these libraries up and get these things going here. And this is how you should have things looking once you're at that stage. So what does Tidy Census need? Well, Tidy Census, let's see, basic usage of Tidy Census. There we go. So these articles that are in the Tidy Census package are incredible. They're very detailed. They're very very descriptive, and more importantly, they get you to actionable data pretty quickly. Pretty quickly, you can get to like a plot pretty quickly with this with this package. What you'll notice here is this thing called Census API Key. right? So the one thing that this package uses is an API key. So what is, are you guys familiar with API keys? Okay, so when machines talk to each other, they talk to each other through what's called an API or an application programming interface. And literally, it's just a way for computers to talk to each other. And to keep just anybody from hitting or from any computer talking to any other computer, programs will often use what's called an API key, which is just a custom key that the host machine will issue to you. So if we just go to this link here, see API census.gov data key and key sign up, we can request a US Census API key. And what that API key will do is it'll give us access to all of the US Census data, which is kind of cool. So all they ask is for an organization name. You guys can put in Spelman. I'll put in Atlanta Fed for me, where I am at, and then put in your email address. So I'm going to put mine, Robertson@btl.frb.org. And yes, I agree the terms of service blanketly without looking at them. I may be volunteering for the draft in my terms of service, but that's okay. The data right now is more important. When we hit the request key, it'll say success, and it'll say your request for a new API key has been successfully submitted. And so you should see an email show up in your inbox shortly with an API key. And I'll wait for mine. Let me see. I think I did mine yesterday. Yep. So I did mine
Where's the
yesterday.
link for it?
So if you go back into, let me go hit back here. So if you go into this Tidy Census project, right? So it's walker-data.com/tidy census. Or if you just type into Google Tidy Census, it'll take you to the same place. Go to articles and basic uses of Tidy Census. And it's in this first kind of block here. You see the little link right here.
I see it. Thank you.
Yeah. And it will spit out. Let me kind of pop this out. I How do I do this? How do I think about doing this? Inbox, but what I want to do is I'll do this. All right, let me show you this instead. Should have something that looks like so you should have an email that looks kind of like this in your inbox. You may need to go to your junk folder if you're using Gmail. But you see this long string here that I've highlighted? That's your API key. Right, that's your API key. So you're literally just going to copy that, Control C or Command C. And we're going to go back over to R. Where's my R? Screenshot, preview window, basic usage, finder, preview data. I don't want this. I want this too. Oh, yes, I do. I want this one.
You're not sharing the R screen.
Yeah, there we go. Share. So go back to here, go back to Posit Cloud. I can just type in API key equals this in quotation marks. We don't want the period at the end, right? So we can just do API. We can just assign it. Oops. API key, right? So now I've got API key. And if I go back to here, I need to feed it into this function here. So I'm going to copy that. This is your API key goes here. I'm going to delete this. I'm going to say API key. If I run that, should do something. Your API key has been stored. All right, here we go. We're good to go. Here we we go. All right, excellent. So it actually did some pretty cool stuff here. So let's see what we can do. Let's try to run this code, for example. So in this basic example, let's look at median age by state in 2020 with data drawn from the demographic and housing characteristics summary file. So age 20, get decennial is the function they're going to call, geography, state, variables, year, and then some file. Do we know what all this does? No, not exactly. We're not exactly sure, but we just know we're going to get the average, or I'm sorry, not the average age, the median age by state in 2020. So we're just going to run this example here. Copy that, bring this over, and it should run. Nope. I need to, what does it my thing say? Your API key has been stored. Let's use it now. Need to run. Oh, forgot to run this. Now I need to run this. So it gave me a message down the bottom. I need to run read environ, our environ. All right. So now if I run this, there we go. Awesome. So when we input our census, when we ran the census API key function, it said that I need to run our read environ. Needed to run this thing here in order to be able to access the API immediately. Otherwise, I'd have to like shut down and restart, which I don't want to do. I'm not entirely clear that I can do since we're in the cloud environment. But if your environment looks like this, you should be in good shape. If you run these three things, you should be in good shape. And then you should be able to run this feature here. And in your output, it should say, did you use a technique that introduces errors into data to preserve respondent confidentiality? Small count should be interpreted with caution. Okay, so it gives us some little messages here about what's going on in the data. And that's kind of cool. And so if I go ahead and view this, all right, so I have geographic ID, which I am presuming is the sort of ID code for the state, which right now have a name. I've got a variable here, which is P13 underscore 001N. What does that mean? No clue. I'm assuming that means it's an age. It's some sort of an age category, and then the value in here is the median age. So this is the median age by states in the 2020 decennial census. So what do you think I can do with this, guys? What can I do with this data?
You said it's the median age of what?
Just the median age by state from the 2020 census.
So you can plot it?
Yeah, I can plot it. That's right. Let's go to ggplot. What kind of plot would I want to do?
Maybe a line plot?
We can do a line plot, maybe a histogram. Histogram would be cool. This kind of reminds me a little bit of the flights data. Remember, you can do the flights data. So maybe do GM histogram. Is it histogram I want to do? Was it GM? Yeah, GM is it histogram or bar? GM bar. Is that what I want? Yes, it is. This is no, I want GM call. GM call has the stats. Remember, GM call. All right, GM bars, GM bar, GM call, GM bar. Next side of the bar, proportional to the number of cases. GM call uses the data in a value. Okay, so I want GM call. Yes, I want X equals, let's say, state. Is that right? What do I have in here? Oh, name. Sorry, name. Name capital Y equals value, right? Let's see, I can do that. And I get this sort of ugly looking thing. Maybe I want name. And then maybe I want value. So remember like we did with the flights data where we had the names on the y-axis and had the values on the x-axis. That's a little bit easier to read. Maybe I want reorder. Remember reorder? I remember reorder. Let's do name and value. Oop. Got to close that out. There we go. So now I've got states ranked. I'm sorry?
Sorry, I'm having trouble. It says in get underscore decennial
Mhm.
invalid char.
Ooh, share your screen. Let me stop sharing. Let's see, states. Yep. You read all that. It could be right here. Oh, ooh. So you ran 789, correct?
Um,
Why don't you
wait, what do you
rerun,
mean?
highlight row or line 789 and just
Oh,
run
yeah,
those.
yeah,
Let's just run those one more time. Okay, cool. Oh, hey, very so you can over. Okay, that's fine. Good. Now let's run line 11. Go to line 11 and then no, don't highlight it. Just
Oh, okay.
unhighlight and just run it by its own. There we go. Scroll down. Oh, you can't really see your screen too well. Are you still getting an error? Yeah, you are still getting an error.
Yes.
Yikes. Malia, are you getting an error also, or are you getting what I'm getting?
I'm not getting an error, but 1 second, my computer is about to die.
Not a problem. Not a problem. We're almost done with the class anyway, so. Let's see now. Scroll down. Okay, good. Oh, down at the bottom. So in your console, just click anywhere in your console. Doesn't matter. Down below. Yep, click there. Hit the escape key now. All right, now go back to line 11 and just rerun that block. Yep. God, getting to using invalid chart in what? That makes no sense whatsoever. I'll tell you what. Let's put a pin in this. After class,
Hmm.
I'll dive into your code directly and see if I can't get it fixed. Is that cool?
Okay, sounds good. Thank you.
Yeah, because I'm like right at the very end. So and I don't know why like your stuff is dying on you like that. Let me go ahead and reshare my screen. Um, so what do I want you guys to do? So as part of the first stage of oh yeah, they did a points, they did a little dot plot here. I did bars. Um, as part of tonight's homework, what I want you guys to do is go through these articles. There's kind of four main articles in here. Um, and what I want you to think about are, um, what are some questions that you guys can think about that you might want to answer with this data, right? So we've got an API key, we've got data, I've got so I can do all kinds of stuff, right? We can do I can do plots, household income by county in Vermont, right? So we can compare county level data. We can compare national level data. We can break it down by sex. We can break it down by race. There's a whole lot of data that we can look at. So this is, it doesn't need to be complicated. Your questions can be directly drawn from this specific website. That's perfectly okay. We don't need to make this more complicated than it needs to be. Um, but there are like other data sets in here. We got population estimates. Um, so we can get, we can use the function get estimates, get population level estimates. So like what was it, one question that came out of the pandemic? One big question that came out of the pandemic was domestic immigration. What's domestic immigration? That's the immigration from one state to another inside the United States. So this is not immigration coming into or out of the United States. This is immigration within states. And so, like one of the stories we heard were people that were fleeing, let's say California for Texas and the Southeast, right? Does that necessarily hold up, right? That could be kind of one question that we may want to ask. You can look at things like net migration, right? There are examples here that we can look at. And you can actually do some interesting plots here, right? So this is something that you guys yourselves, if you just copy and pasted their code into your script, you would be able to generate an interesting plot here showing the net migration. So in this case, the blues are migration out, the reds are migration in, and this is net migration per 1,000 residents by county. So looks like a lot of people moved into Florida in 2024. It looks like some folks are moving out of, let's say, like maybe Northern California a little bit. But it looks like a lot of the net migration was happening like in this middle part of the country. A lot of folks moving out of the Midwest, and to some extent, Alaska for some of the sunnier parts of the country, right? So I've got Florida, Arizona, right, is another one. The Las Vegas area is another hot spot. I'm sure if we zoom in quite a bit, it looks like there's a little zone here in Atlanta, right, that can be of interest. And so, one interesting question is like, so where are people, moving to Atlanta from, right? We might be able to ask with this. So, let's see, we have data dictionaries. One's data estimate API, which includes information on a wide variety of data. If I go and open this new link, what do I get? Population estimates API. And I get a bunch of vintages, and I get categorical variables. Here we go. So if you just hit the link on these data sets, population estimates API, and I go to the categorical variables, these give me all the categorical variables that are associated with this data set. So I've got age group, I've got geographic summary levels, I've got, oh gosh, a lot of age groups, population groups, sex, Hispanic origin, right? So on and so forth. And I can do that. This is for 2023. I can go to the population estimates API 2023, right? This kind of, gives me, I've got some questions here, housing unit estimates, all kinds of stuff, all kinds of data. So your homework tonight is to just kind of go through the website. I don't want you to do any coding. I just want you to get familiar with the data. If you guys have questions, let me know. If you guys are struggling a little bit, maybe we can all come up with some questions together tomorrow. From here on out, this is all we're going to be working with. Right? So no more homeworks other than just sort of what we want to look at. And together as a class, we're going to go through that iterative process of how do I look at the data? How do I come up with a question? And how do I answer that question with the data that I have in front of me? This is gonna be your guys' part. This is the time. You've got 2 weeks of me droning on at 8 a.m. about R, and it's been a struggle, but you guys have done fantastic. Now this is your guys' time to shine. So we'll use class time, and if you guys need it, we can use office hours afterwards to get through the rest of this. I will draft up a quick little document for you guys to give you some better sense of direction about sort of what the expectations. So, think about, come up with a question, and we'll just do a simple presentation at the end of next week that you guys will present. That'll be your deliverable, and then maybe a little one-page write-up. Right? Give me a little one-page write-up. Can be in Word and PowerPoint. We don't have to do it all within R, but your plots will be done right in R. If you want to export your data to Excel and do some formatting in Excel for some fancy tables, we can definitely do that. I leave the table formatting and doing everything in what we call Markdown for my 3000 level class. I'm not going to expect rising sophomores to be able to attack that. That's a lot to bite off. But yeah, so this would be kind of like what I think you guys have done presentations like this before in other classes. And so this will be very, very similar. But again, it's a forward class. My expectations are pretty modest. But kind of want you guys to get your heads wrapped around this. This is data you are going to see like as you go through your classes. You are going to be messing with this. And if you are doing internships, particularly at the Fed, I can almost guarantee you will touch the census data at least once. How does that sound? Does that sound reasonable? So your homework tonight is just go through the website. Go through this website, not this website, this website, and just play around with it. Right? Get familiar with the package. Run the functions here. Try to generate their data. See how they go through it. And then if you can, try to come up with a question that you think you may want to answer with this data. So again, it could be something by race, can be by sex, can be by geography, can be by occupation. It can just be population trends in the last census. It can be any number of things. Sound cool? Awesome. All right, that's all I got. Easy peasy. And this will be the last thing that we do for this class. So here on out, this is what we're gonna be working with. Sound good? Cool. All right. Well, I will leave that to you. Alyssa, you don't have to stay on. I'm going to dive into your code right now, though. And so if you get a disconnect and pause it, that's me in your data. And I'll just send you a quick email when I'm wrapped up. Sound good?
Okay, sounds good. Thank you.
Cool. And guys, for the folks that are currently doing their internships and are watching the videos after the fact, play around with this data set. And if you have questions, email me, you guys here right now. If you have questions, you run into a brick wall at any time, shoot me an email, and we should be able to get you guys rock and rolling here. Cool. All right. Well, enjoy the rest of your day, and I will see you tomorrow.
Thank you.
Good day.
Awesome. All right. Bye.